Sorry, my chat's off. Yeah, so it needs to pass that horizontal line test, right? And so if it's one-to-one, that means it does have an inverse. So the inverse of an exponential function turns out to be a logarithmic function. But why do we need those logarithmic functions? What it comes down to is that sometimes we can look at an exponential equation and we can solve it by inspection. So when we say solve it by inspection, it means really you should just be able to look at it and know the answer. Right? So if we say 5 to the x equals 5, you should be like, oh yeah, x is 1. I can just see that. Or if I say, well, 5 to the x is 25. Oh yeah, x is 2. We can just see that. If we say 5 to the x is 20, and that shouldn't be something we should just know. Okay, so that's where a logarithm would step in to help us actually find that answer. But what we should know is that the answer there is somewhere between 1 and 2. Okay, and so we have that idea, but if we actually really want to know what the exact answer is, or as close to the exact answer as we can get, that's what logarithms are for. Okay? And I really want you to make sure you guys look at that word, and it's kind of a tense-looking word, right? Logarithm. You don't see a lot of words like that. It's an operation, guys. Logarithm is something you do to a number. It's like division. It's like raising something to the second power. It's like adding 2 to it. Okay, a logarithm is really just an operation. We take logarithms of numbers. Okay, logarithm itself is nothing. That's just like saying square root. Square root what? I have to square root something in order to make it do, or something to be there. So it's the same thing. Logarithm. You take a logarithm of something. Like what's the logarithm of 4? Like that's an answer. It's something we could answer. Okay. So it's just something we do to a number, right? And so what they're, here in the bold, a logarithm is a quantity that represents the exponent to which a base must be raised to produce a given number. Even though there's nothing like particularly, there's really no big words in there, right? It's still just kind of written in a difficult, I think a kind of difficult way, okay? At its heart, okay? Giant red letters, okay? Stars all over. What is a logarithm? It's an exponent. Okay? A logarithm is an exponent. So part of what we're going to be doing today is I'm going to be showing you guys how to read these, talking to you guys about how to read these, how you just say this, okay? So this is log base 4 of 64. Log base 4 of 64. How you read that is the exponent, right? Log is an exponent to which 4 must be raised to produce 64. Okay? I'm going to reword that here. So one thing I do a little differently is I always put what's called the argument in parentheses. Okay, so you'll notice that the text is doing that here a little bit. Like it says log base 2 of x down here at the bottom. It says log of x. It says the natural log of it. We'll talk about this stuff down here in a minute. But notice how the arguments here are in parentheses. And then we come out here, and then now they're not. So I'm very consistent about doing that. And I always put my argument in parentheses. Okay. So I would just suggest that you guys do that same thing. So how do I read this? Log base 3 of 9. So one thing you need to make sure you're doing here is that this 3 needs to be small and needs to be low. It basically should be exponent sized, but it needs to be low. It should not be high. All right. So it's an exponent is what's called a superscript. This is called a subscript. Okay. So it needs to be small and low next to the log. So log base 3 of 9, and then the log and the 9 should be your normal sized handwriting. So one thing we're going to have to watch out here for is your handwriting. Okay, so log base 3 of 9. What this means, right? So log base 4 of 64. The exponent to which 4 must be raised to produce 64. I think that's really way overly wordy. This log base 3 of 9 means 3 to the what power is 9. Okay, and this is the foundational stuff I was mentioning earlier that we're going to hit really hard today. Okay, how do you read this? What does it mean? Log base 3 of 9 means 3 to the what power is 9? Okay, and then we can answer that, right? So log base 3 of 9 must be 2. Okay? Because 3 squared is 9. Okay? So before we move on to doing that a bunch together, just going to look down here at the bottom. So exponential functions and logarithmic functions, remember those are inverses of each other. Okay? That those would undo each other. So remember our parent function for exponentials is 2 to the x. That's the most basic exponential function. So the inverse of that would be log base 2 of x. So notice how the base of the exponent, base of the power became the base of the log. Okay? F of x equals 10 to the x would be log of x. So what this is called the common log. So when we write log without a base like that, it's assumed to be log base 10. We're going to talk about this more later, kind of more formally, but this is log base 10. So this is essentially like the same thing that, we write x. There's a little 1 right there. There's a 1 out here. There's a 1 down there. Right? There's all those ones that we just assume. The assumed coefficient, the assumed denominator, the assumed power, right? We also have that here for like the square root of x. It's assumed that that's a 2. If it's anything else, we have to say, right? Well, the assumed base is 10, right? Because our number system is based around 10, right? So the assumed base is log base 10. So if it just says log, when you look at your calculator, right, you have a log button, okay? That's log base 10. And if it's anything else, you have to write it. So if we want log base 2, we need to write that. If we have log base 12, we need to write that, okay? That's called the common log. It's log base 10. I talked to you guys in the video on Tuesday about e, like where e comes from, what it's about. And so this number e we use is called the natural log. That's called the natural base. And so then the natural log is log base e. So log base e like that. Like of x is the same thing as the natural log of x. So we don't write this. We don't write it this way. This is the way you write it. Okay. So it's called the natural log. This is the natural base. It's written ln because the French came up with this. It was the logarithme naturel. So it's written ln. I've had students in the past think that this was an I. It's not an I. It's an L, natural log. Okay. So if it says ln, that means we're talking about base e. These things are essentially vocab, guys. You need to know them. If it says log x, that's log base 10. If it says natural log, it says ln, that's base e. Again, you guys have a natural log button in your calculator. Okay, it's over right next to the log button. Okay, and notice that the second function on log is 10 to the x, and the second function on ln is e to the x. Right, so they're kind of even telling you what the bases are there next to those. Do any of you guys not have like a scientific calculator at least, or a graphing calculator that you have access to? Are you talking about on your phone, Malaysia? Is it a calculator, or are you talking about the graphing? Yeah, Desmos is just graphing. I'm talking about an actual calculator. Anybody else not have? So mainly what I use for myself, right, I've showed you guys this app many times, is this EduCalc app. Okay, sorry. Yeah, it's up there in the center of my desktop there on my phone, or my iPad. Okay, if you have an iPhone, this one works really well. It's free. Just search free graphing calculator right on the App Store. The Desmos app on the Android I believe has a good graph, like good scientific calculator with it. So if you have an Android phone, you can look at that Desmos app. I'm sure there's other ones. If you have an iPhone, this free graphing calculator, which is called EduCalc, is a really one I've been using for years. So, like if I needed to use a log on this, and you don't see log anywhere here, where the log is on this app is over there on the left side where it says func. Okay, so on the functions, so I hit that. You can see the natural log up there at the top, log base 10. There's one below that we won't mess with. But there's your the two that we would need, natural log and log base 10. Okay, so making sure that you're going to have access to that. You won't need it today, but it is definitely something you're going to need in the futures. A scientific calculator or a graphing calculator with logs on it. All right, so I want you to turn to page 96, and then we're going to use the blank page next to that. So it's actually on the back of page 95. Malaysia, let me know if you can't get anything, okay? All right, so on that blank page, I want you to go ahead and write down the stuff here in the blue and the stuff in the green. Okay, exponential form, a to the x equals y, and I want you guys to write down how you say that. So a to the x power equals y. Logarithmic form, log base a of y equals x. So, and I want you to write this down. How do you say that? Okay, and then we're going to start doing this here together. And there are quite a few of these, so you kind of we're going to eat up most of that page as we're doing this. And then as you're laying it out, I also need to make sure that you guys keep space here. We need a little bit of workspace. So really probably about as big as you wrote this needs to be blank space here next to it, so we can do a slight amount of work and then the next column over. Okay. So I'm going to give you 2 minutes to at least get the green and the red, the green and the blue stuff down, and then I'm going to have you turn your camera on and show me what you got. Okay, all right. So let's look at this. Lead you through these real quick. Okay, I'm going to do the first two, and I'll start calling on you guys to do it. Okay. So the first thing I want is for you to read it. Okay, I need you guys to be able to communicate how you say this. Okay, so it's purely just reading. This is log base 3 of 27. Log base 3 of 27. Okay. What we're going to be getting to is that we're going to be able to move between these two forms fluidly. And it's really going to be one of those key things to this, your ability to work with logarithmic equations and exponential equations, is that if you're trying to solve an equation that's in this form, if I'm trying to figure out what x is, okay, I have to be able to turn it into this to figure out what x is. Notice how x is isolated here now. Okay, in this way, if the x was here, if I want to solve for y, and it's in this form, I want to solve for y. Well, if I just transfer it to this form, now y is isolated. Okay, so the transferring between these forms, that fluidness is going to be so important for you guys to solve these types of equations. So log base 3 of 27, that's how you say it. And what does it mean? It means 3 to the what power is 27. So log base 3 of 27 means 3 to the what power is 27. Well, 3 to the third is 27. So we can tell that by inspection. So log base 3 of 27 must be 3. Okay. Log base 5 of 25 is how I say that. That's how you read that. Log base 5 of 25. What does that mean? It means 5 to the what power is 25. I'll give you a different way to say that. 5 to the what is 25? 5 to the what power is 25? What do I raise 5 to in order to get 25? More wordy, it's harder to say. Okay? 5 to the what exponent is 25? Okay? So that's what we're asking here. This is a question. Okay? Log base 5 of 25 is a question. The question is 5 to the what power is 25? Again, we should know that by inspection. 5 squared is 25. It's 2. Okay. All right, who's feeling brave? Want to start off this process? Who can read this for me?
Is it log base 10 of 10?
Log base 10 of 10. Wonderful, Ruth. So then, Ruth, what does that mean? Log base 10 of 10, what does that mean? Just asking for this.
What exponent of 10 equals 10?
Okay, what exponent of 10 equals 10? And I'd probably find it easier just to say, less words would be 10 to the what is 10, right? Same thing. So 10 to the what is 10, Ruth?
1.
10 to the 1 is 10. So log base 10 of 10 must be 1. Okay, thank you, Ruth. Who's next before I start calling on you? Else feeling brave?
I can do the next.
Yeah, Maddie, awesome. What's that? You read that, Maddie.
Log base 10 of 100.
Log base 10 of 100. What? Perfect. Then what does that mean?
10 to the what exponent equals 100?
10 to the what exponent equals 100. So then what's the answer to that, Maddie?
2.
10, yeah, 10 squared is 100. So log base 10 of 100 is 2. Thanks, Maddie. All right. Tiger, you're up. Read that for me.
Log base 7 of 14.
Log base 7 of 14, perfect. And what's that mean?
What to the power of 7 equals 14?
What to the power of 7 equals 14?
Yeah. Or 7 to the power of what equals 14?
There you go, 7 to the power of what equals 14. Do you know that answer?
No.
It's definitely not what.
It's not squared.
Yeah, that's right. The trick I was trying to play with on you guys, right? It's definitely not squared, right? So we don't know that answer, right? So we were able to see the other two by inspection, but sometimes we don't know the answer. And again, that's why logs exist, is to get those answers that we don't just know. Okay, this is really why we need a logarithm, is to answer a question like this. 7 to the what is 14? And I was just messing around last night trying to figure that out. So this is me playing earlier in fourth hour. So I got to that point. So you can see 7 to the 1.35 is 13.8. 7 to the 1.35 85 is 14.6. So you do is like 7 to the, so you start just messing around, like I'm going to go a little bit lower, 1.35, 82. Let's see where that gets me. Oh, that's 2, not far enough. Like, so I can see, I'm sorry, again, just trying to delete, get it down a little bit lower. I'm getting pretty close to 14 there, right? 7 to the 1.3565, I'm getting really close to 14, right? I think last night I was able to get down to 4 zeros. Okay, we can kind of see what exponent we would need, and in the end it would be an irrational number, a never-ending decimal that doesn't repeat. Okay, so it exists, it's just not easy to find. Okay, so but we don't know that off the top of our head. All right. Okay, thanks, sir. Ray, what about this next one? Just read that.
Log base 1/2 of 1/8.
Okay, log base of 1/2 of 1/8, perfect. And then what's that mean?
1/2 to what power equals 1/8?
Right. Yeah, and as we do this, because it is a fraction, we would have to put 1/2 in a parentheses, okay, so that the 1 and the 2 are both being raised to the same power. Thanks, Ray. So what is that? What would our answer be there? 1/2 to the what is 1/8?
Would it be 3?
3? Why is it 3, Grant?
Because it's 1/2 to the third power. Well, that's what I put into my calculator, at least.
Well, what's 1 to the third power?
3. Or that's incorrect.
What's 1 to the third power?
1.
1. Okay, let's do the third power.
That's 8.
Okay. So 1 to the third power over 2 to the third power is 1/8. So 1/2, log base 1/2 of 1/8 is 3. Thank you, Grant. Alasia, what about the next one?
Is it like log of 10 is 0.1 or something? Base of 10.
So
Wait,
log. How'd you say it?
log base of,
Is there an of there?
no,
Yeah, so just log base.
log base 10 of 0.1.
Yeah, so log base 10 of 0.1. Okay, and then what would that mean, Alasia?
Okay. Is it like, I don't know, I'm having trouble.
Yeah, so this is log base 7 of 14. We said that's equal to 7, or it doesn't equal, sorry. Log base 7 of 14 means 7 to the what is 14. Log base 10 of 10 meant 10 to the what is 10.
So log base 10 of whatever equals 0.
Sorry, I couldn't hear you.
Log base 10 of whatever is 0.1.
No, so I'm not saying log base 10 again. You know, log base 10 of 100 means 10 to the what power is 100. Log base 1/2 of 1/8 means 1/2 to the what power is 1/8. And I'm not saying log anymore. So 1/2 to the what power is 1/8. So what's this mean?
10 to the what power is 0.1.
Yeah, 10 to the what power is 0.1. Okay, so you're like, you've got a different type of thinking here, right? We've got to read this and completely translate it, right? So that's what we're working on here. So 10 to the what power is 0.1. Thanks, Lasia. 10 to the what power is 0.1. Victoria, why is it -1? How'd you know that? You there, Victoria?
Yeah, I don't know. I just put random numbers in my calculator.
Okay. So, Victoria, what's another way of saying this? It's another way of saying 0.1.
I don't know.
Okay, let's go broader. Guys, what's another way of saying 0.1? Yeah, 1/10, right, Rhea? So if 10 to the negative, 10 to the what is 1/10, right? What type of exponents do we need to get fractions? Right? We need negative exponents to get fractions. So that's where we get the 10 to the 1, -1. Okay? So seeing that is seeing it a different way. Okay? This be helpful. We know that we need a negative exponent, and 10 to the first is 10. Okay. Piper, read that for me.
Log base 2 of -8.
Thanks, sir. Well, what's that mean?
It's 2 is to what power equals -8.
2 to the what power is -8? Okay. So what would that be, Piper? 2 to the what power is -8?
couldn't you not do it since it's a negative?
Yeah, all right, exactly. It's not possible. That does not exist. Okay? There's no power we can raise 2 to get negative 8 as an answer. Right? What do we, we definitely don't want to think it's negative 3, right? 2 cubed is 8. So then we're like, oh, negative 3, right? But negative 3 would give us a fraction, not a negative number. So why can't we do that? Okay, that's what it comes down to. Remember that logarithms are the inverses of exponentials. And so we'd be taking the inverse of 2 to the x. Well, we graph 2 to the x, right? What did the graph of 2 to the x look like? You guys just did that, right? It was an exponential function. Started off real close to that x-axis and it curved up, right? But it never touched that x-axis. It never went below that x-axis. It only went up. Right? All of the values were always positive. Well, if all of my y values are always positive, when I inverse that, that means all of the x values that I'm allowed to use in a logarithm must be positive. I'm not allowed to take the log of a negative number. So this is what makes that math go bad. Okay? You're not allowed to do that. So it's kind of like dividing by 0. It's not that it's tricky, it's impossible. Okay? This is tricky. This is hard to figure out, but it's possible. This is impossible. It does not exist. Okay? Thanks, Pepper. Cole. Read this for me.
Log base 0 of 4.
Log base 0 of 4, perfect. And what does that mean?
Zero to the 4th exponent.
It's 0 to the, kind of breaking up.
Is it to the 4th exponent?
Yeah. So choppy, I can't hear you. Sorry. Riley, can you pinch it? What's this mean?
It would mean that 0 to the 4 equals something.
What was the last thing you said?
Equals, I don't know. I'm not sure. Just
Okay, so we say log base 7 of 14. That meant 7 to the what is 14. And, log base 1/2 of 1/8 means 1/2 to the what is 1/8. So when we say log base 0 of 4, what would that mean? Still looking at you, Riley. Log base 2 of -8 meant 2 to the what is -8. Log base 10 of 100 meant 10 to the what is 100. So what is log base?
0 to the power of something equals 4.
Okay, so 0 to the power of something is 4. Or what power of 0 would equal 4? What is that, Riley? 0 to the what is 4?
I'm not sure.
Okay. What's 0 to the first power?
0.
What's 0 to the second power?
It would just be 0 for all of it, so it wouldn't work.
Yeah, there you go. Right. Doesn't work. No such thing, right? So what's making that go bad, right? We're not allowed to have a log base 0. Okay. Why can't we do that? Okay. Well, f of x equals 0 to the x would be the inverse of that if we were going to do that. But this is not a one-to-one function. Well, if it's not one-to-one, that means it has no inverse, which means there can be no log base 0. Okay. And we also see why it just doesn't work, right? 0 to whatever is going to be 0. Can't be anything else. So it just doesn't work. Okay? But it really comes down to that 0 to the x is not 1 to 1, so there is no log base 0. Thanks, Riley. Katie, I heard from you yet?
Log base 1 of 2.
Log base 1 of 2, awesome. And what would that mean? You still there, Katie? What would that mean?
Oh, it means what power of 1 equals 2.
What power of 1 equals 2. And what's the answer to that, Katie?
I think it doesn't work.
Yeah, it doesn't work, right? Because 1 to the what? Any power is what?
1.
Yeah, right. So there's nothing I can raise 1, 2 to get 2, right? So that doesn't work, right? And why doesn't it work? Because we're not allowed to take log base 1. And again, it's the same reason, because this is not 1 to 1. So it does not have an inverse. Okay? Cannot take log base 1 of something. All right? So, Victoria, I haven't heard you read one yet. What about this last one?
Is it -4 to the power of 16? Oh wait, that's
That's
wrong.
what I'm asking right now. I just want you to read this.
Log base -4 of 16.
There you go. And then what does it mean?
-4 to the what power equals 16.
All right, good. And because it's -4 like that, that part would have to be in parentheses. Okay. So what -4 to the what power is 16?
Just 2.
2, right? So it works, right? -4 squared is 16. So we can maybe think that this would work, but it actually doesn't. There are very few numbers there that I could have plugged in that would actually give me answers. Like if I plugged in 4, log base -4 of 4, there's no answer for that. Log base 4 of like 64. I'm trying to think of numbers that are, like powers of 4. Log base 4 of 64. There's no answer for that. So I picked one of the few numbers that would actually give us an answer, but most numbers within the parentheses there would not give us answers. And so this one also does not work. And again, for the same reason that f of x to the negative of negative f of x equaling negative x, good lord, -4 to the x power is not 1 to 1. When we defined exponential functions the other day, the bases of those had to be positive numbers. They couldn't be 1. We said that b had to be a positive number. B could not be 1. And so b had a positive and b couldn't be 1. Right? And so in the same way, the bases of bases of logs have to be positive, and they can't be 1. Okay? So we're not allowed to take the log base of a negative number, or a log base of 0, or a log base of 1. Those don't exist. So a log base has to be positive and not 1. Right? We saw positive numbers that were smaller than 1. That's fine. That worked. Okay? But it can't be 0, it can't be negative, it can't be 1. The argument of the log has to be positive. So that means it's not negative and it's not 0, but it can be 1. Okay, you're allowed to take the log of 1. That's fine. Okay, so these are some of the restrictions on logs. Like, we can't just log whatever we want, however we want. Okay, there's some restrictions, kind of like we can't divide by 0. Okay. Again, this skill, guys, for you guys to be able to manipulate a logarithm and move it into an exponential form, or the other way around, is going to be, again, foundational for this class. Okay, for us to be able to translate between these two things smoothly, efficiently, is going to be key. Okay, that's where we're going to look next here on 96. Okay, so log base 2 of 32 equals what? Because why? All right, so what does log base 2 of 32 mean? What's this mean? Grant, what's this mean? Yeah, 2 to what power is 32? Great. So 2 to what power is 32? Translating that into a question. You guys really do need to read this as a question. This is asking you something. Okay? You've got to turn that switch in your head. This is a question. 2 to the what is 32? Well, 2 to the 5th is 32. So log base 2 of 32 is 5. Okay? This is a question. And if you don't read it as a question, you're going to struggle. You've got to take that and say, what is this asking me? It is a question. It doesn't look like it, though, but it is. Okay? That's where this switch you guys got to flip. Okay? Key idea, a logarithm is an exponent, right? I wrote that down earlier, big red letters, right? Stars all around it. Here it is again. The logarithm is an exponent. Okay? Is equals. This equals an exponent. Okay? There's the exponent. So we're going to use that idea that the logarithm is an exponent to help us translate. Okay? So where do these numbers go? How do they move in the problem? Okay? So our base of our log is the same as the base of our power. The exponent of our power is the answer to the logarithm. The argument of the logarithm is the answer to the power. How do the numbers move around? How do I translate them? What's the pattern of movement here? Okay, if I wanted to go from one form to the next, how the numbers move. Okay? So if it's in exponential form and I want it to be in logarithmic form, I know my answer is going to look like this. It's going to be log base something of something equals something. Right? I need to fill in these 3 spots. What's my base? What's my argument? What's my answer? Well, the base, I think, is the easiest part, because the base of the power is the base of the log. So that's going to be log base 2. The next thing is, for me, the exponent, because the exponent, a logarithm is an exponent. When I say is, that means equals. A logarithm equals an exponent. So then what's left? Well, the argument. So the log base 2 of 8, okay, equals 3. Then you should look at that and say, does that make sense? What does log base 2 of 8 mean? Piper, what does log base 2 of 8 mean?
2 the exponent of 3 equals 8.
Yeah, I was just asking for the part, just the left part, right? 2 to the what is 8, right? And you say 2 to the what is 8? 3. Oh yeah, 2 to the 3 is 8, right? That it should make sense. Okay, when you guys are doing this translation here at the very beginning, because notice we don't have any variables, okay, your answer should make sense. Does 2 to the 8 equal 3, right? When you say log base 2 of 8, that means 2 to the what is 8. Well, 2 to the third is 8. So does your answer actually make sense? When we throw variables in there, guys, you're going to lose that ability to check to see if what you did is correct. You're going to have to trust yourself. And so you really need to be good with this. This needs to be down. Okay? So we look at 3 to the negative 2 equals 1/9. How do I move that stuff around? So log base something of something equals something, right? I need to fill in those blanks. Again, for me, the easiest place to start is the base, because that's the same as the base of the power. So I look at the base of the power, I know that's going to go there. So log base 3. A logarithm is an exponent, so I need my exponent next. All right, that's why I like to go. So my exponent and log is an exponent. That means it goes across the equal sign. And I just have that leftover blank to fill, so it must be 1/9. Then I cover up that negative 2 with my thumb, and I go log base 3 of 1/9. What does that mean? Log base 3 of 1/9. That means 3 to the what is 1/9? Well, if I'm getting a fraction, I must have a negative answer. And then 3 squared is 9, so it must be 3 to the negative 2. And I uncover my answer and say, oh yeah, negative 2. Okay? How do you check this to see if it's actually working? Okay? Does this actually flow? Okay? I need you guys good at this. Not doing that last one. Okay? What about the other way? Okay? Log base 2 of 64 equals 6. Okay? What I'm going to end up with is a power, or a base to a power equals another number. Okay? A base to a power equals a number. So again, I always like to start off with that base, because that's the same as the base of the log. So I'm going to have 2 to the something. A logarithm is an exponent. That means my exponent is on the other side of the equal sign. So 2 to the 6th. And what am I left with? I'm left with the 64. 2 to the 6th equals 64. Does that make sense? Does 2 to the 6th equal 64? Well, if you work it out, yeah, it does. If you did it any other way, this would make no sense. 6 squared equals 64. No. Well, 64 squared must be 6. Not quite. 6 to the 64th power must be 2. Ooh, not quite. Like, none of these make sense. Okay? Does this flow? Okay? So what about this log base 1/3 of 27 equals negative 3? How do I rewrite that as an exponential equation? What you got, Maddie?
Isn't it 1/3? And then the exponent would be negative 3 equals 27.
Okay. So I think here we need to add is, there should be parentheses here just because it's a 1/3. So does that make sense? Right? Does 1/3 to the negative 3 equal 27? Well, negatives flip things. So I would flip it back to just being a 3, and then 3 cubed is 27. Checks out. Good job. Okay. I'm not going to do C here with you. Right? These last ones were really what we were just doing on the other page. Log base 3 of 9. What does that mean? Tell me what it's equal to. Right? Your job is to say this is equal to whatever. Well, log base 3 of 9 means 3 to the what equals 9? 3 squared equals 9. So log base 3 of 9 must be 2. Okay. Andrew, what does this mean? Andrew, what's that mean?
Log base 4 of 164.
That's how you say it. What does it mean? I want this.
Oh, you want that? Wouldn't it be 4 and then 4 equals 164?
4 to the what equals 164? So we have to figure it out, right? Well, our answer is a fraction, so that means we know our exponent must be negative. And then we say 4 to the what is 64. Well, 4 cubed is 64. So it must be negative 3. Okay? How do you figure that out on your own? How do you do it by inspection? Okay? It's negative because it's a fraction, and then 4 cubed is 64, so it's negative 3. Okay? So tomorrow I'm going to need maybe like 5-10 minutes from you guys. We'll do this stuff. I'll try to formalize the natural log and the common log stuff for you guys. The rest of the time you'll have to do your homework. Homework is long, but all the problems are really short. Okay? It's just doing this. That's all the homework is just rewriting. I really want you guys to be good at that. Okay? I haven't said that enough for you to understand. Okay? All right?